Okay, in this video, we are going to look at surfaces. So first off, it says give an example of a single variable function. So this is something you should be used to. An example of a single variable function would be something of the form f of x is equal to x squared plus 3, for example. Okay, this is a single variable function because the output of the function depends on only one variable, which is x in this case. Now, if I went to sketch my function, I would need a pair of axes. This will be my x-axis, and then the vertical one you could call f of x, or you could potentially just call it y as well, okay, as sort of f of x takes the place of y. So that's your single variable function. What we're going to be focusing on in this topic is multivariable functions. So this is one where the input and or output consists of multiple numbers, okay, multiple variables. So an example would be something of the format. So for a single variable function, it's often referred to as the format y equals f of x. Now for our multivariable ones, it's going to be of the form z is equal to f of x, y. So z is going to depend on two inputs, x and y. So an example of something that is in this format would be z is equal to 3x take 5y. Okay, that is an example of a multivariable function. Now, another way this could potentially be written is it could just be written as f of x, y is equal to 3x take 5y. And then another completely different format for our multivariable functions would be, for example, g of x, y, z is equal to some constant c. So I could take what is written here and rearrange it into this format. Okay, what I could do is subtract the z to the other side. So I would get 0 is equal to 3x, take 5y, take z. Okay, and now it is in that format where the c in this case happens to be 0. Okay, so you can do similar for some of our single variable functions. Okay, you could, if we had y is equal to x squared plus 3, you could rearrange into the format 0 is equal to x squared plus 3 subtract y, for example. Now this equation here, if I was to draw its graph, okay, this would give me a surface. Now in terms of how I would do that, how I would get my surface, okay, what I would do is I would plot all of the points that satisfy that equation there. So for example, if I said x was 1 and y was also 1, I would then substitute those values in to find z. Okay, so I'd have 3 times 1, which is 3, take away 5 times 1, which is 5, so 3 subtract 5 would give me negative 2. Okay, so that would be a point on my surface. Let's get another one. Let's go with x is 0, y is 1, and let's figure out what z is. So 3x would be 0 if x is 0, and then negative 5y, negative 5 times 1 would give me negative 5. Okay, like that. Now let's say I wanted to get my surface, I would need to plot all of the points that satisfy the equation. Now in terms of how I would do that, I need to start drawing my axes, but this time we are going to draw 3 axes. Okay, so you're going to have your y-axis and your x-axis, which I will draw first. Like this, so this is y, this is x, and then you would have a z-axis, which is at a right angle to both of those, okay, going upwards like that. So the z coordinate essentially represents sort of the height of the point. So if I wanted to plot these points, this first one, we got x, we got y, and then we got z. So we got 1 in the positive x direction, so that would be here. We got 1 in the positive y direction, so that would be sort of over here. And then from there, we would go down to, okay, so if I extend my z-axis downwards, I'd sort of go down. And it's hard to draw this out, okay, but essentially negative 2 would be sort of down here. So your point, you could put it there if you wanted to, okay. But essentially, that's how you'd plot that point. And then you do similar with the 0, 1, negative 5. Okay, so 0 on the x-axis, then 1 again on the y-axis, but this time we're going to do -5, which is going to be even lower. So you could potentially draw it sort of down here, okay, where this is -5. Okay, it's not realistic to plot every single point on the surface, and actually you won't be expected to draw any surfaces in this topic. But I do just want to talk a bit more about what a surface might actually look like in full if we did plot all the points. So a single point, has no dimensions. Okay, it's got no length, no width. Now a line, well, that has length but no width. Okay, so that is a one-dimensional drawing, which we could draw on a 2D axis. We could technically draw a line on a 3D axis as well. Whereas your surfaces will be two-dimensional. They'll have length and width. So an example of a surface might look a bit like this. Okay, and this surface in particular, okay, what I've drawn here would be a plane. A plane is much more like a sheet of paper. And actually, you've looked at planes before when you were doing matrices. You were solving systems of three simultaneous equations in three variables. Those equations in three variables you were dealing with were planes. So this equation here, this z is equal to 3x take 5y, is an example of a plane. If I was to plot all the points, I'd get a sort of rectangular looking shape like that, which has length and width, but it has no thickness. Okay, it's not going to become a cuboid, for example, like that. Okay, it's just the rectangle that you sort of see there. Now you can have more than two variables. Okay, so it's possible to have more variables, such as we got w as another variable is equal to a function of x, y, and z, but we're not going to be looking at that now.